Since these problems are important, I'll make sure to emphasize them. Let's get right to finding the answers. When the diameter of the transducer increases, the near field in the A mode also increases accordingly. Although this is a basic concept, it's a frequently appearing pattern, so make sure to organize the concept through solving problems. Let's look at problem number 122 right below. You can just review this problem for reference. I'll explain which parts of the problem you should focus on, highlighting the key points. Since the content of this problem isn't particularly important, let's go straight to the answer. This question asks how many pulses are needed to create an image when there are 4 transmit focal zones in a linear array system. You can consider that you need as many pulses as there are focal zones. Rather than focusing on the specific content of this question, it's important to note that as the number of focal zones increases, the frame rate decreases. In fact, questions related to this topic are being asked more frequently. As mentioned before, when the number of focal zones increases, focusing becomes more precise, and there is the advantage of improved lateral resolution. However, the downside is that the frame rate for reproducing the image decreases accordingly. So, make sure to organize and review the relationships related to focal zones. Once again, just keep this question in mind as a reference. Focus on organizing and reviewing the parts presented here. Next, let's move on and look at question number 123. This question contains important content, so I want to emphasize it. If you look at the content, it explains that in the linear array method, the examiner adjusts the focusing during the examination. So you can think of it as a situation where the focus position is changed arbitrarily. The question is asking which type it is among the options. The correct answer is option C. In the case of multi-zone transmit, it refers to a term where the examiner can arbitrarily adjust the focus. On the other hand, options A and B are methods where the device itself adjusts automatically. So, rather than the examiner adjusting it, you can think of it as automatic focusing within the equipment itself. Options D and F are examples of typical mechanical focusing. I think it's probably option D. Mechanical focusing is a method of focusing using mechanical means, such as shaping the crystal or making external modifications like this. The characteristic here is that the focus is fixed from the beginning, so it cannot be adjusted. So you can see that these expressions are not related to the idea of manipulating the focusing. Therefore, through the question, you can see that this part is handled by the device, and here the focusing is already determined. So just make sure to note that the option that the examiner can adjust is option C. Next, let's move on and look at question number 124. You can consider questions 124 and 125 to be about the same topic. Electrical focusing is possible, but electric steering, is not, so there is a representative probe that uses mechanical steering. The correct answer is the annular array, which is listed in option 2. Also, if you look below, the fact that both elevation and lateral resolution are measured together is another representative feature of the annular array. So, since questions 124 and 125 are frequently asked and follow an important pattern, make sure to review and organize them. Next, let's move on and look at question 126. Let's solve this problem quickly using the related keywords I explained earlier. The first clue is the mention of a linear array. There are additional sentences stating that a mass in the thyroid area is being examined. Next, there's the term out of plane, which refers to slice thickness or elevation, used to describe the thickness of a cross-sectional image. I mentioned before that these two don't go well together, so instead of choosing the good option, you should select the one that is not favorable. The most representative example is focusing, which comes up as the main topic. Mechanical focusing is achieved at this point. You can consider elevation as the correct answer. If you are familiar with just these two keywords, I think you'll be able to quickly find another related keyword as well. The more complicated a problem is, the more important it is to find a quicker way to solve it, and that's something I can recommend. Next, let's move on and look at question number 127. This problem is simple, yet it's a pattern that appears frequently on tests. The method by which an image is created in a rectangular format in a square shape can be selected as option B. Therefore, since the characteristics of the rectangular shape, the convex shape, and finally the advantages and disadvantages of the sector are always likely to be tested, you need to organize and review these topics as well. Additionally, you should also make a note of which parts are examined using these types of images. Next, let's move on and look at question number 128. If you look at the question, it asks you to find another name for axial resolution. One of the things I always emphasize when you study is the presence of synonymous expressions. Especially in English, it's important to know not just a single term, but many synonyms that have the same meaning. Likewise, for axial resolution, the representative synonymous expression can be seen as option D. The remaining options A, B, and C can be considered synonymous expressions for lateral resolution. So, when you study, make sure to organize terms that have the same meaning together. Next, let's move on and look at question number 129. This question is asking about techniques related to dynamic apodization. The keyword associated with this here is side lobe. The correct answer can be chosen as option C. Usually there is a main lobe. Dynamic apodization is applied to reduce various phenomena that occur in the side lobe formed on the side. As a reference, these techniques apply a high voltage to the main beam and a lower voltage to the side lobe to reduce such phenomena. So just make sure to note that the keyword side lobe is associated with the terms mentioned here. Now let's look at question number 130 right below. Yes, this follows the same pattern as the content we solved above. Let's solve it right away using the keywords. A linear array is being applied here. Among these, it is asking which resolution is the worst. I've emphasized that among axial, lateral, and slice thickness, the relationship is not good with slice thickness. The correct answer is elevational or slice thickness, so you should choose option C as the answer.